Heat and AC test 8. In a reciprocating piston compressor, this is an air conditioner compressor, the pistons are driven by what? A wobble plate, a crankshaft, or a swash plate. The swash plate, you know, and a wobble plate are very similar in the way they do, but the pistons act slightly different. All of these is the right answer for that. Most York compressors use cylinders made from what?
Aluminum.
Probably aluminum, yeah. That's a good answer. All right, let me do something here. Let me make this happen here. All right, now then, the reciprocating piston compressor used on many older General Motors vehicles is designated what? That's going to be the one that you're working on, Dustin.
R6.
That's an A6. When they say older General Motors compressors. The two technicians are discussing variable displacement piston compressors. How would you do that? Technician A says a wobble plate is moved to the high angle position for maximum output when the cooling load is high. Technician B says a wobble plate angle is controlled by the pressure in the crankcase. Which technician is correct?
Well,
Yeah, well, but whenever you're variable, when you got a variable piston, I mentioned this last week, you typically don't have an AC compressor clutch. This compressor spins at the same speed all the time. You can't disengage it from the hub. The way you control your pressure is you actually change the, if the wobble plate's causing the pistons to go back and forth as it spins, if you change the angle of the wobble plate and bring it back to the center, it's basically going to make it just not compress anything. They'll be spinning, but they're not going to be moving back and forth. So it's really cool because it's like a variable, infinite variables there if they do it right. Okay, the General Motors variable displacement compressor has how many cylinders? This is book stuff here, right? A, 5 or 7, odd numbers. Which of the following is an advantage offered by a scroll type compressor? Low engagement torque, smooth engagement, ability to use a small clutch, all of these. Now, why would you have to have a bigger clutch? Remember what I told you about your accessories? The ones that are the hardest to spin are the ones with the biggest pulleys. Power steering, AC. Now the AC compressor on that one you're doing is not quite as big as we're seeing on some of these other ones. But if it's kind of hard to operate the compressor, they're going to put a big pulley on it because you got a big pulley, you got a lower ratio, right? That means it's easier to pull because you got more traction surface on the pulley, the size of the pulley. It's going to turn it slower, but it's going to turn it with more power. Power steering pump's the same way. The water pump is kind of a big pulley typically too, and in a lot of cases, sometimes it'll be spun by the timing belt or the timing chain. Let's see, the scroll type compressors, I will tell you this, well, I got one of those around here somewhere that we've torn apart. It came out of Michelle Goosby's car, and those compressors like to wear out. I don't really like them that much. What typically happens is they just get to where they're not pumping anymore. If you hook your gauges up and you turn on your compressor, you turn on your AC and you see your compressor spinning, but you're not building, you don't have a lot of differential between your low and your high, that typically means your compressor's gone south, and that happens. What amazes me is the one that you pulled off turned so easy with your hand, but it was still working. That one over there, but the new one is kind of stiff that he's putting on there. What's used to seal the opening for the compressor drive shaft?
lip seal.
Well, it can be a lip seal or a carbon seal cartridge. And a carbon seal cartridge is a real polished thing that slides against there. We used to have to replace those on the home compressors. At the dealership level, you'll do a lot of repairs that you won't do working in an independent shop. Like for instance, at a dealership level, if there's an engine is under warranty and there's something that goes wrong with one of the cylinders, like piston ring issues or something, you will pull that one piston and put rings on that one piston and put that one piston back in there. They don't have you replace everything, like a total overhaul, because there's not, and they're in the amount of the engineers, one that particularly was kind of new, there's no need to. Let's see. Two technicians are discussing refrigerant oils. Technician A says mineral oil used in R12 systems is completely compatible with R134A. Technician B says a synthetic oil should be used with R134A. Who's right about that? That's B. Two technicians are discussing TXVs. Once again, what's a TXV? It's on the tip of your tongue, right? Quincy? What's a TXV? Thermal. Give me the next word. Expansion valve. Now, I will tell you this, in most of your shops, they don't call it a TXV, they just call it an expansion valve. Got it? All right, expansion valves, the ones, and what's the difference? We see what replaces the expansion valve on the one that doesn't have an expansion valve? What does that job? The orifice tube. You won't have an orifice tube and an expansion valve unless you've got a front and a rear unit and you're in a van. Got it? All right, so anyway, two technicians are discussing thermal expansion valves. Technician A says thermal expansion valve senses evaporator temperature to control the valve opening. Technician B says the thermal expansion valve senses evaporator pressure to control the valve opening. Who's correct about that? Actually, both of the guys are right. Now, it's got a tube. Well, some of them are just a square block that are all made together. But some of them, you'll have that, like on that Cadillac you're working with, Dustin, you have a little small line here going through the expansion valve. And I'm just going to draw this real simply. And right here, you got a little diaphragm. And it typically will have this thing on the older one and on a lot of newer ones too, snaking off of it. It's a stiff alcohol line. And here's your suction line right here. And this thing will be over here hugging your suction line. It'll be clipped around it, it'll be taped to it or something, because the temperature of that suction line is going to be translated into movement here that's going to control that expansion valve as that refrigerant going through it. And that's basically how that works, but it also senses the pressure too. All right. All right, stay with me now. What we got here? Skip over here. We need to know this stuff here. Two technicians are discussing AC systems. Technician A says a thermal expansion valve system uses a receiver dryer mounted in the suction line. Technician B says orifice tube systems use an accumulator in the suction line. Who's right about that? What did I tell you guys about the difference? Joe, who are you talking to? You want to share that with the rest of us or what?
I'm not talking to nobody. I'm looking on the internet about how often the planes go down.
Oh, come on.
Constantly.
Nobody's going to make you get on a plane if you don't want to, Joe. All right. Which one? What's the difference between a thermal expansion valve system and an orifice tube system as far as where they put the dryer? Remember that? We talked about that at great length. All right. Look over there on that chart on the board. What kind of system is that? Doesn't it say with the little words? What does it say, Joe?
Various models.
Huh?
Various models.
Various model. Okay, what you got right here? What is this right here in the liquid line? That's the liquid line right there, right?
That's the receiver dryer.
That's a receiver dryer, and you got an expansion valve too, right?
Yeah.
All right, look up here. Look at that one, right? Wait a minute, that one. What's this right here?
Low pressure cutoff switch.
All right. In that liquid line somewhere, there'll be an orifice tube. They may have it pointed right there. Yeah, I can't read it from here. Well, look at that on the suction line, the big line coming to the compressor, you got an accumulator. So look at the difference where they put them. They put the ones that have an expansion valve have got a receiver dryer in the liquid line, and the ones that have a orifice tube have got a accumulator up there close to the evaporator. And that's always the way they're set up, typically. Once again, if you got a van, it may have an expansion valve in the back and an orifice tube in the front, if it's got two different units in it. But they're both using the same compressor. All right, so number 10, let's read number 10 again based on what I showed you. Two technicians are discussing AC systems. Technician A says TXV system uses a receiver dryer mounted in the suction line. Is that true?
No.
That's wrong. Technician B says orifice tube systems using an accumulator in the suction line. Is that true? Yeah, it is. That is true.
So it's
An accumulator in the suction line. The suction line is the big line that comes from the evaporator to the compressor. And that's where the accumulator is going to be found on orifice tube systems. The fitting found on an accumulator is for which of the following? A, leak detection. B, low side service. C, high side service. Or D, flushing.
D.
Actually, B, low side service. Low side service.
What's the high side service?
The high side's going to be on the discharge line usually, because the low side, the accumulator's in the low side. Now think about this. You notice how the accumulator is so big and the receiver dryer is so small? Why would they make the receiver dryer small and the accumulator big? Why not make both of them big? Because you got pounds per square inch. Okay, what is the pressure going to be running in the liquid line?
Higher than the gas.
A lot higher. I mean 250 or 300 on a hot day. On the suction, what's it run on the low side line?
100.
No, on the low side line it runs about 40. That's rough, but I mean when the system's engaged. Now whenever things shut off, your static pressures are going to be close to the same. But good, you may have good static pressure and still have low refrigerant, so don't go by static pressure. All you'll know is there's some refrigerant in there. You don't know how much is in there. But if you pull out what's in there and you put back the right amount, you'll know what's right then. On a cold day, all the pressures are going to be lower than they are on a hot day. If you got a 100-degree day outside, your pressures are all going to be higher. If you got a 70-degree day outside, the pressures are going to be lower. So it's really subjected to, ambient temperature. It's got a lot to do with it. Let's see. Filter can be installed in the liquid line for which of the following? A, when the system's contaminated. B, instead of flushing the evaporator. C, when the extra moisture removal is needed. Or all of these. Just A, when the system is contaminated. Now what Ford used to have us do was we would put a fairly large filter that was, you had to cut the line, put some swedge fittings in there, and put a fairly large filter in there in the liquid line. Now why would you put it in the liquid line? Because you want to catch it when it's coming out. I mean, on the pressure side going. What's the flow? The flow is from compressor, discharge, condenser, liquid, evaporator. Suction goes back to the compressor. So before it ever makes it back to the compressor, before it even makes it to the evaporator, there's a filter in there that's going to stop all the trash. You run it for about 30 minutes to an hour with the AC running, and all of that filter catches all the trash that's in there, supposedly, and then you take that filter out and you put another one in there that's permanent. In other words, you throw away the first one you put in there. That's what we used to do. And that was a procedure that was that Ford had us doing. Let's see. There's also, there's a sheet I gave you guys a while back, kit. Now you might have noticed that the suction line on that compressor you're putting on has a screen in it. That screen is to catch any trash that happens to be in the system before it ever makes it into the compressor. And some of the compressor builders and manufacturers put those in there. But your old compressor had a screen in it too, see? Frigidaire had a pretty good idea when they put that in there. Now you can go back and add a screen to the other ones, and I got a kit in there to do that. It's cost about $100 for that kit. Let's see. Two technicians, or wait a minute. The pressure cycling switch does which of the following?
C.
No, that's the cycling switch. Think about the low side switch that's on the accumulator, and when the pressure goes low, it turns off a compressor. Now that's one of the ways that the ones that are, GM and Chevy did that, and some of the other ones did too. But that keeps the compressor, the evaporator from freezing up, because low pressure means low temperature. So if the pressure goes too low because it's low on refrigerant or because it's getting too cold, it's going to shut the compressor off so that it doesn't just keep pulling things down. What happens if the evaporator temperature goes below 30 degrees, or goes actually below 32? It starts to freeze up. All that water that's dripping out on the ground turns into ice. The next thing you know, you got a big block of ice in there. There's no air that can come through your evaporator. All right, let me see here. Two technicians are discussing line fittings. Technician A says, many early AC system used flare fittings. Technician B says, modern systems commonly use O-rings to seal the fittings, and these are much easier to repair than flare fittings. That's actually C. The flare fittings. I will tell you this though, if you pull grill off of a Chevrolet pickup and you go down there to take that, these 90s vintage, and you go to take that line off, I mentioned this last week, the liquid line that comes out of the condenser, if you ever have, the orifice is right there. That's why you have to take it loose. And if you start trying to take that loose, you're going to wind up, it's galled. Those threads are just about always galled, and you will not, about one time in 15, you may get that line off of there without destroying the line in the condenser. So if you ever have to put an orifice in there, you may as well get a condenser in that line. It's really hard to, it's like pulling a cylinder head off a Trailblazer. You're going to break some of the head bolts pulling the cylinder head off a Trailblazer. I mean, they're going to pop when they're coming off of there. General Motors says to whack them so that they are less likely to break. But when they break, there's a $400 special tool you got to use to get them out of there, supposedly. But I don't know why they do that unless they're just too brittle to be torqued to yield or something. I don't know. One way or another, that's a nasty mess. Whenever something like that always happens. The hose that connects the compressor to the evaporator is commonly called the what? We've been talking about that.
Line. Suction line.
The compressor.
Gas line.
It travels from which to from what to what? I mean, the refrigerant's flowing from what to what?
This the discharge line.
From the evaporator to the compressor. Think about the direction it goes, okay? And so that's the suction line. That's the big line. That's the line that gets cold. And if you're working on something that doesn't have any specs, if you just put refrigerant in there until it's finally gets cold all the way to the compressor, you know you got enough refrigerant in there. If it's only cold part of the way to the compressor, you're still low on juice. But if you're using a machine and you've got literature available, like I'm talking about if you're working on a piece of equipment out in the field. I went out there one time to help a guy put an air conditioner compressor on a knuckle boom that had lost its refrigerant because the compressor went bad out there in finger steel. I wrote an article about it for Action Magazine. It was something I did while I was on spring break. But I went out there and there was no specs on that thing. So whenever he got his refrigerant, and when there's no specs on it, you fire it up, you start the compressor running, you have your compressor going, your refrigerant hooked up to the low side line through your gauges, and you keep filling that suction line until it's cold all the way to the compressor. When it is, you got enough. You know what I mean? That's how you do that. I will tell you this, that sometimes it takes a long time to pull that juice in through the suction side. Even if you get a can from the store or something, let me see here. Huh?
Would it be the cold gas line then?
No, it's actually going to be the suction line. A fixed orifice tube does what? It's usually located in the evaporator inlet or the line to the evaporator. You can usually look at that liquid line and you're going to see a place close to a fitting that's pinched. That's actually had a little crimp, mild crimp like on three sides, and that's where your tube is going to be. That's all you got to do. There's going to be a fitting on that liquid line somewhere close to one of the fittings. You'll see where that thing is. Now on these Jeeps like that one Ed had out here, remember that the Jeep Cherokee we worked on, the white one, you cannot replace just the orifice tube. On that one you got to replace that whole liquid line. And it's got the orifice built into it, and it's down in the middle somewhere. All right, let me see. Which type of refrigerant hose is used with an R34A system? Barrier hose, R134A is a smaller molecule than R12. If you have a little leak on an R12 system and you convert it, you'll then have a big leak of R134. An air conditioning system may use an inline filter to do what? Prevent any solids from clogging the expansion valve. There's something else a lot of people don't know about that a lot of these vehicles do. Ford calls it compressor anti-slugging strategy, and some of the other people do it too. If the compressor is mounted low, what does the oil tend to do? The oil tends to pool up in the compressor. What were you looking for?
17.
17 is the barrier hose. That's the oil slugs in the compressor. So what they do is, while they're starting the car, they energize the compressor and they let it spin slowly along with the engine, and it moves any oil out of the way so that the compressor doesn't get slugged and stop trying to squeeze that liquid oil, see? But they call that CAS, compressor anti-slugging strategy is what Ford calls it. GM does it too. A bunch of them do it. They don't talk about it. But if you're ever spinning one over and you see the compressor spinning while you're spinning it over, that's what's going on. It doesn't mean there's something wrong, Especially if it's mounted low. If it's mounted high, you don't have that problem, but if it's mounted low, you do. I see Joe looking at the clock. Joe, are you a clock watcher?
Yeah.
All right then. Okay. Now 18, an air conditioner may use an inline filter to prevent solids from clogging the expansion valve. An air conditioning system may use a muffler to do what? Come on, guys, don't play dumb with me. What do you use a muffler for? Reduce noise, okay? What's the function of the desiccant bag inside an accumulator?
All the above.
No, it's A. It captures and stores moisture.
See, I have one of the letters.
That comes under the heading of wild
What was
guess.
13?
Oh, 13 was A. The variable displacement compressor uses what?
A variable angle wobble plate.
Well, to begin with, they misspelled impeller. It should be ER, not OR. It uses 4 pistons. That's what it does. All right. But it also uses a variable angle wobble plate, so duh. Better put B on that if you don't want to get it wrong. Which of the following is not a major component of most compressors? Piston and rings is in there. Clutch is there. Fins and tubes you don't have on a compressor. What is the component shown here? What is the component shown here?
High voltage compressor package.
And you know this how?
High voltage wire, bright orange.
Very good. They had to show it because it wasn't printed in color, right?
Yeah.
So that's a high voltage compressor package. Okay, identify the component illustrated in the next picture. What's that?
Accumulator.
Accumulator. You knew that because you changed one last week, didn't you? All right, keep going. Almost done. Identify this component. What is this component here?
Receiver dryer.
Good show, Joe. Actually, it's a C. Actually, that's not right. 25 is actually A. For a second, I got crossed up there, but I know that is definitely not an accumulator because there's a lot more going on in an accumulator than there is here. As a matter of fact, I got it right up there. I got an accumulator cut apart, and there's the little receiver dryers up there too. Some receiver dryers are built into the end of the condenser. All right, we're almost done here. A damper drive compressor turns the compressor input shaft when? Anybody know? Whenever the engine is running. That's what I was talking about earlier. They're ones that are variable displacement. 27, true or false, compressors on some vehicles use a clutchless design and a variable displacement. I talked about that already. That's true. Some systems have a modulator instead of a receiver dryer. That's true. Choose the one alternative that best completes the statement. A compressor clutch that cycles on and off rapidly is an indication of what?
Low idle speed.
Well, that is not so terribly wrong. That's not the answer the guy that wrote the test wants. I've seen that because a lot of these engine controllers are monitoring idle speed. If it goes too low, they'll kick the compressor off. Tell you something else they'll do. If they perceive an engine temperature that's too high, they'll turn off the air conditioner. I actually had one with a bad engine coolant temperature sensor that would turn the AC compressor off when there was no real reason to, but it thought the engine was hot because the engine coolant temperature sensor reading was skewed and it was making it seem hotter than it was. Basically, on this one here is a low refrigerant charge. You see one short cycling, I'm going to be checking the refrigerant first. You know where it goes click, on, and then off. Click on, and then off. That's refrigerant is low most of the time. However, on a really cold day in the wintertime, when everything's low, that may not mean low refrigerant. It may just mean that ambient temperature is cold. Anybody got any questions or comments about that? All right. Now then, I want to get that PT Cruiser, and I think the key's in it out there, and I want to move it into that service bay over there. And the reason I'm putting it over there is because I really don't like this lift on this end. So